What is an autonomous database? Well, let's go straight to the website. Now, it's secure, reliable, high-performing, and so on. And that's what we see here. There are all sorts of white papers about it. But in general idea, it's self-driving. The automation database provisioning, it really is just click, 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 or there is an API. Tuning and scaling can also be fully automatic. The tuning is using all of the latest facilities for automatic monitoring, automatic index creation, all that sort of thing is enabled. Scaling as well. There are financial implications to that, of course, but you can configure service levels that you want Oracle to monitor, not Oracle in terms of human beings, you want the Oracle database to monitor itself. And if your critical services are not meeting the performance levels they're meant to meet, more resources can be automatically added to your autonomous database. The security should be absolutely unbreakable. And there's no point in even discussing it. It's just perfect. I don't believe there's any way anyone could get data off an Oracle autonomous database unless they were given permission to do so. The self-repair is quite phenomenal. Automation of failure detection, failover and repair, it works superbly. It works superbly. There really should be zero downtime. Oracle could lose an entire data center, and your users currently connected to an autonomous database might not even notice that it has happened. That is a superb capability. So that's the sort of marketing stuff. Well, I should mention at this point, it's secure, reliable, high-performing, on-premises or on Oracle Cloud Infrastructure. The dreaded OCI, yes. For it to be on premises, you need to be a pretty high budget user there because it's all Exadata. So you'll need a pair of Exadata machines. You buy Exadata boxes in pairs. You'll need 2 of them on premises, and then you can install it all on site. Today, we're aiming everything at people running on OCI. We're assuming you're going to be cloud customers. Whether it's on premises or OCI, Oracle does a huge amount of the management for you, in particular patching and backup, and a lot of other stuff too. Control over patching, not much. Control over backup, not much. The assumption is that Oracle knows best. Uncle Oracle will look after you as far as this sort of thing is concerned. Well, that's the marketing business. But what actually is an autonomous database? It's a PDB. So we're in the world of acronyms here. A PDB, a pluggable database, also known as, there's another acronym, a pluggable container. So it's a pluggable container, a pluggable database within a CDB, a container database, a multi-tenant database. I'm sure some of you will be fully familiar with multi-tenant architecture. So I don't want to go into and put in questions if you wish, but we haven't intended to go into discussion of multi-tenant architecture, PDB and CDB today. But it's worth a brief mention that PDB, multi-tenant architecture, is unavoidable once you get to release 20, and this is an example of why. An autonomous database is a pluggable database within a CDB. It's hosted on Exadata in an Oracle data center. So what you get with a PDB, for those of you perhaps who may not be familiar with it, a PDB is in effect a virtual database. There is one huge physical database running on an Exadata box. That astronomically large physical database might be hosting dozens, hundreds, even thousands of pluggable databases. And your PDB is like a virtual database within that one physical database. You can make a very close analogy with virtual machines and physical machines, PDBs and the CDB. And the fact that it's a PDB opens up all sorts of possibilities for fault tolerance and more. The PDB architecture is very good. I'll stop talking about it after one more comment. Even if you are running on standard edition on premises and you have only one database, even so, multi-tenant is worth going for, believe me. It took me a couple of years to be convinced, but I am now. So an autonomous database, you are renting a PDB hosted on Exadata in an Oracle data center.
Couple of questions, John.
Please.
So does it run on Oracle database appliance?
I don't think so. I don't think you'll get most or any of the autonomous facilities on a database appliance. I can't imagine how it could be ported to it. I could be wrong, but if it were ported to an ODA, you would be missing out on an awful lot of capabilities. So I don't believe they're going to do it.
Can I create more PDBs in ADB? Yeah, back to you, John.
That's an interesting question. No, you can't. I've had to do reverse engineering on this, of course. That question must have come from someone who knows about multi-tenant architecture. When multi-tenant first came out, you had your CDB, and within it's your PDBs, and it was just two levels. There's the root container, the management tool, and the PDBs beneath it. When you get to later releases of 12c, you can create what they call application containers. And an application container gives you a multi-level structure. From the root container, you create your application containers, and within your application containers, you create pluggable containers at the next level down. You can't do that, as I understand it, with autonomous as it is today. You are at the bottom of the tier.
Thanks, John. I'm going to the guests, students here today, I'm going to be posting some stuff in the chat, tutorials, links, and class information on things coming up. Back to you, John. Thank you.
Okay, so it's a PDB hosted in Exadata. Rack and data guard, that's all there. That's all there. You can't switch these facilities off even if you wanted to. And that's what a lot of the fault tolerance comes from. What you get within the database, it's Enterprise Edition plus virtually all the extras. So you are getting hundreds of thousands of dollars worth of software per core in ADB. ADB, that's the acronym Autonomous Database. So that's what it is. This is how incredible it can be. Now, whether you believe some of what we see here is, of course, your choice. But this was one of the first papers describing autonomous database. Oh, we're wondering how old this is. Oh, September 2018. Right. If you look at the uptime arrangements, it is absolutely phenomenal. So going to uptime, here we are. Replacing manual tasks with extensive automation, of course, they can reduce administration costs by 80%. Well, whether that will mean that half of us get fired, I don't know. But that's the theory anyway, that us, the users, won't have to spend too much resources on administration. You've got the auto scaling as well, so it can scale up and scale down in response to demand. But here's the phenomenal statement. Oracle also offers a 99.995% uptime guarantee for the autonomous database, 2.5 minutes of downtime per month. It gets better. Unlike other cloud providers, Oracle's uptime guarantee includes planned maintenance. And that is phenomenal. So the uptime guarantee is not only downtime because something went wrong, it's downtime because of things like upgrades and patching. And that is absolutely phenomenal. However, I have noticed that when you go to this link here, so that first was the white paper that defines autonomous, introduced it to the market. But I did check out the service level agreements for the current release. And we see here slightly different. We see that this is for all of the OCI components. And we see here autonomous is only 99.95%. I say only, and that would be what, about 22 minutes downtime a month. So there does seem to have been some going backwards on that first original promise. But even so, 99.95, including planned maintenance, is phenomenal. I do not know, by the way, what the financial backing to the service commitment actually is. I can't comment on that. One way or another, we're talking a highly available environment. How on earth do they do it? It's the combination of rack and data guard and multi-tenant. So maximum availability, rack plus data guard. I'm sure many of you are running in MAA environments already. You don't have to configure it, they do it for you. Adding on, and that alone can reduce your downtime and data loss, possibly not to zero, but down to single-digit seconds for downtime, especially when you consider the multi-tenant architecture. A particularly powerful capability of multi-tenant is the hot cloning of a PDB. The hot cloning of a PDB. Your pluggable database, your PDB, is currently located in a CDB on the Exadata box in one data center. It can be relocated to a CDB in an Exadata box in a different data center, and the downtime for that relocation might be single-digit seconds. Now, the technology behind this is all to do with pluggable container hot cloning, which I use all the time. I was doing it today, just setting up a standby environment for one of our production systems. And that's just standard multi-tenant capability for really fast relocation. When you add on the MAA functions, which would be for handling unplanned issues, that's how they can get to these phenomenal uptime guarantees. I haven't had the opportunity to fully test all of this, but certainly application continuity is there. I'm sure many or most of you will be familiar with the concept of TAF, transparent application failover, and FAN, fast application notification. Application continuity takes that to a new level. TAF and FAN cannot, in their basic form, protect in-flight transactions. If there's a database availability event while a transaction is in progress, it's going to get rolled back. Well, application continuity can even protect in-flight transactions. I haven't had the opportunity to see how well that works myself, but I can understand how it can function. And I'm prepared to believe that it can work in this environment. We also have auto scaling, and that's where they are using, I warned you about acronyms, QoS, quality of service. Quality of service was announced, I think, in 12.1. I don't think it was available before then. Never really worked, except perhaps some Exadata. But quality of service in the Exadata environment can monitor what's going on. You can specify response times for certain services, and if they are not being achieved, the quality of service mechanism, in conjunction with grid infrastructure, will allocate more resources, perhaps even start more instances to a particular service. So auto-scaling, guaranteeing service levels. There would, of course, be cost implications if that kicked in.
Is the uptime something we have to configure, push and click and push, whatever, or is it something that comes automatically?
It comes automatically. I don't think you could stop it even if you wanted to. It's the whole business of rack and data guard. It's just there. It isn't something you configure. It isn't something you pay for.